Yeah, Mariam. In the last class, we had started with resistance and resistivity, and we have completed all the separate topics also which were present. So now we have to start with three important topics: terminal potential difference, internal resistance, and EMF. Now I'll start with internal resistance. It's a very small, short topic, so it's easier for you to understand. Look, what is meant by internal resistance first? Suppose this is the inside of a battery and we have electrodes present. These are the electrodes present. Within this, there is an electrolytic solution which is present here. So what are the things? These are the electrodes. This is the electrolytic solution. Now, when the current will be coming and it will pass through these. So there will be a resistance offered by the electrodes as well as the electrolytic solution. This is called the internal resistance, and this actually appears within the battery itself. This is not visible to us. The cell is present, and this internal resistance of the cell is this. So this actually happens. Whatever is the resistance offered by the electrodes and the electrolytic solution, it is called the internal resistance. Write it till here, then I'll start with EMF. Okay, class. Now EMF, the next topic. So EMF is basically electromotive force. Now, what is electromotive force? It's a misnomer actually. This is not a force. The way we have frictional force and gravitational force, viscous force. So electromotive force is not that force which you have studied in your laws of motion. Electromotive force is just a name given. It's actually the potential difference. You can use and replace it with voltage also. So electromotive force is actually the maximum potential across the terminals of a cell. All right, class. So when we're talking about EMF, electromotive force, this is not a force. Firstly, keep this in mind. And when we are talking about it, we should have this in mind that this is voltage. So all the properties of voltage, all the SI unit and everything of voltage is valid over here, which is the electromotive force. So it's actually the potential difference. But what is important here that it is for an open circuit. Like if this is a cell, remember one thing, this is the higher, the longer side is the higher side, higher voltage. And this one is the shorter side. So this one is the higher side, this one is the shorter side. So this is VH, this is VL. So EMF is VH minus VL, and here the EMF is VH minus EL. Everywhere we'll have it, it's just that the signs will be different automatically when we'll be subtracting it. Fine. So whether it's this case or this case, EMF is this. So it's the maximum potential difference across the terminals of a cells in an open circuit. If we have the same thing for a closed circuit, then we call the quantity as terminal potential difference. I'll tell you that. First, write it down. Electromotive force. Okay, class. So as I was saying, this was the electromotive force was the potential in an open circuit. If the circuit is closed, then we say it's the terminal potential difference. Now, class, one thing, look at this figure. This is very important for us to know about the terminal potential difference and EMF. Instead of remembering this open circuit, closed circuit, why not to remember something which is used most of the time, right? Why not to use something which is used most of the time? Like if I give you an example, this capital R, it represents the external resistor. Small r represents the internal resistor. Now, whatever is the potential difference across the external resistor, we call this as terminal potential difference. Terminal potential difference. And this we call as the internal resistor. And the potential difference across this internal resistance is what we call as the EMF, electromotive. This is a very good way to remember. That's why we always mark this E across the internal resistor. An internal resistor is always made beside the battery, not in this gap. Whenever internal resistor is made, it is made adjacent to the cell. This is a combination which is very well used. External resistor can be many. It can be n number of resistors can be there. And the way we reduce everything, parallel combination, series combination, everything we can solve and finally make a final R equivalent action. That we will see, so which we have studied in capacitor also. So that portion we will see. Now class, look here. So R equivalent is actually the external resistor. But I'm not writing it as R equivalent because we do not know whether there is a single resistor or more than a single resistor. But you already know that this is R equivalent. And this is small r equivalent to. All right. Now this is our Ohm's law. V is equal to IR. Current will be from here, potential divided by the resistance. What is the potential? EMF of the cell. Resistance is the external resistor plus the internal resistor. So current, this is actually the formula of current. And current is E. E is the EMF divided by capital R plus small r. So this is the external resistor and this is the internal resistor. Now look, this is the current. Now I want to find out the potential. This was the EMF. If I want to find out the potential, now how will I find out the potential? So see, V is equal to I into R. So current is E by R plus R and this is the external resistance. So using our Ohm's law, we can calculate the potential also. This is the potential difference. Just be aware of the terms because this becomes confusing at times. Because everything is just potential, potential, potential. Internal resistor, external resistor, all these things are there. So just be careful which term is being asked. Now look, potential, see if I is the current across the entire circuit. I is the current across the circuit. So if I want to find out the potential difference specifically for the internal resistor, using Ohm's law, I will get V is equal to I into small r. If I want to get the potential difference across the external resistor, I'll get V is equal to I into capital R. So this is the potential difference across the internal resistor, potential difference across the external resistor. All right. Now, this is the main formula which we use. So see, this is the potential difference This is a potential difference. So net potential difference is E minus IR. No derivation for this. Simple. Remember this formula, and it's a very important formula. We'll see some more thing about this formula. First, write down everything. At least have this in your notebook. Write it once so that it gives you a little clarity. Then I'll talk about it. Write it. So yes, class, this is the external resistor present. This is the internal resistance and this is the EMF. So in the first part, very clear, I is equal to E by R plus small r. So this is 22 by 1 plus 10. That is 22 by 11, which is equal to 2 amperes. So this is the current in the circuit. This is 2 amperes. All right. Then potential difference across external resistor. So potential difference across external resistor when we are calculating, that is I into external resistance. So it is 2 into 10, which is equal to 20 voltage. Third is across internal resistance. So potential difference across internal resistance. I'll write small r so that it becomes easier for us to differentiate between capital R and small r. So this is 2 into 1, which is equal to 2 volt. Last part says the voltage, I guess, terminal potential difference. So V is equal to E minus IR. So E is 22 minus IR is 2, which is equal to 20 voltage. Right? Any other part? No. Write down the solution. Then, okay, let me tell you this as well. Then you can copy down. It's complete. It's a very short topic. Now we'll come to series and parallel combination. C class, if it is getting discharged, that is the charges are current is moving from the positive terminal and then through the circuit entering into the negative terminal. Then we use the formula of terminal potential difference, what I've told. Just in case if you encounter this scenario where it is charging, current is entering the EMF, positive terminal and then moving from the negative. So from negative to positive, it is E plus R. So this is from positive to negative. And this is from negative to positive. And one thing, if the current is 0, that is your open circuit. So V becomes directly equal to, these are just some note points. Write down this and add the note point as well. Now, before we start with the series and parallel combination, see, we were talking about a single cell continuously. Now, if there are more than one cells present, then what we have to do? So EMF will directly be added and internal resistance will also be added like this. See, all the equivalent EMF and all the internal resistance will be added. But if we have any of these changed, like instead one is put like this, there's a change here. Then you have to subtract an EMF. But resistance can never be subtracted. So resistance will be added. It's just that that EMF of that particular cell will be changed. Write it, then we'll discuss this question. After this, we'll then start with the reversing of cell. This I'll tell you in detail. And then we'll start with series and parallel combination. Write this first. Okay, class, let us discuss this. See, the EMF, the internal resistors are present and the EMFs are present. So when we have to calculate E equivalent, We'll add all these. So it is 10 plus 5 plus 15, which is equal to 30 volts. And what about the internal resistor? 2 plus 2 plus 1. So R equivalent will be 2 plus 2 plus 1, which is equal to 5 ohm. And external resistor is 10 ohm. So when we are calculating the current is equal to E equivalent by R plus small r equivalent. E equivalent is 30, capital R is 10 plus 5. So 30 by 15, which is equal to 2 amperes, right? Then we have terminal potential difference across 10 volt. See, 10 volt, when we have to calculate the terminal potential difference, means that is the first part, V is equal to E minus IR. So what is the EMF that we have to choose? 10 volt, because it is being asked, right? Current is 2, resistance is 5. So it is 0, answer is 0. Write down the solution. This is the solution. Rishita, which are you asking me to show the question?
No, thank you.
Now for the reverse cell, this I was mentioning that, see, even if one of the cells is reversed, like this one, so E1 minus E2 plus E3 like this. And for the internal resistance will always be added. Mention this also, reversing of cell, then I'll start with series combination. After this, I'll start with series combination. Okay, now the series combination. So in series combination, I have told you earlier also that potential changes because the wire is same, but devices are present and devices change the voltage. So if devices like resistors are present, even when capacitors were present, the voltage used to change. So we'll get different voltages, but the current through the circuit will remain the same. Like in capacitors, charge was the same. Here, current will be the same. So current, here if we add all the potentials, V1 plus V2 plus V3 till Vnth, then total current multiplied to the total resistance will be equal to I into R1 plus I into R2 up till I into Rnth. So see, all the current will be cancelled. So R equivalent formula. We'll just add all the resistances. R1 plus R2 plus R3 till Rnth. Alright, this is the formula for equal resistance. Now, if we have to find out current through each resistor, so see, current through each resistor, I1 is equal to I2 is equal to Inth. All will be the same because this is series. So in series combination, all will be the same. Then voltage through each resistor, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3, like this. So when you have to find out the resistances of individual, you can find out using this also. Otherwise, these voltages. So for nth, we'll use I into Rn. All right. Then power dissipated. So P is equal to I square R. Now look, this is, if we write P is equal to I square R equivalent. So that gives the total power. And this is P1 is equal to I square R1, P2 is equal to I square R2, P till Pnth is equal to I square R nth, like this. Write down